framework for evaluating AI agentic systems and measuring, of course, performance. Michał, if you're ready, the floor is yours.
Hello, everyone. Thank you, Maria. And let me share the slides.
Yes, please.
All right. So, good afternoon. My name is Michał Junczyk, and together with the team, we are representing Allegro. Today, we are going to talk about AI evaluation. Lately, you might have noticed increased interest in AI evaluation or evals across different roles. The reason is that AI systems are unpredictable by nature, and this means traditional software and product testing methods are no longer enough. But we are here to bring you some good news. The localization industry has been doing work directly relevant to AI evaluation for many years. Basically, language teams are the experts at measuring quality in specific business contexts. And in this presentation, I will show you why language teams hold the key to trust in Agentic AI. And in our workshop, right after, we will build a baseline AI evaluation system together. So let's get started. First, some quick context. Allegro is the largest native e-commerce marketplace in Central and Eastern Europe. We come from Poland, and we currently serve over 20 million active buyers across 4 major markets. In 2023, we launched the Allegro marketplace in Czech Republic. Then we expanded to Slovakia and Hungary a year later. Each new market was launched faster and more effective than the last. And as you know, every new country has its own language nuances and cultural expectations. Therefore, our goal is to make the shopping experience feel local to every Allegro customer. At Allegro, we divide our AI strategy into 2 streams, external and internal AI solutions. In the external AI, we use conversational agents to reshape how shoppers buy and partners run their operations. We also use AI to scale and optimize our ads and marketing. In the internal AI stream, we accelerate our product development. Thanks to new tools, we now ship software ideas in weeks instead of months. Secondly, we also improve operations and internal processes. And last but not least, we give every employee a personal AI tool. This helps everyone work smarter and faster. So let's now just quickly focus on our recent innovations in external AI stream. This year, we have released 2 in-house built AI assistants. These solutions are already making life of our shoppers and partners much easier. And specifically, AI assistant for shoppers let our users search like they're talking to a real person. For example, our AI can answer questions about products and remember the conversation context. The AI assistant for selling partners act as a 24/7 support, helping to navigate across documentation and sales center tools, as well as manage daily operations. It is worth to mention that we have nearly 100 AI projects running today. And of course, this growing adoption and scale lead us to the big question, how do we actually measure if our AI systems are actually good? So this is where our team steps in. We are the Data Annotation and Quality Assurance Services team, or DAQAS in short. Our main mission is to scale trust in our AI across all languages. To achieve this mission, we combine scalable evaluations and expert standards. Basically, we own the quality standards and the QA tools, but we also act as a bridge. Our function is to connect internal teams with their specific needs and expertise with the industry-leading tools and vendors to achieve proper scale and efficiency. At all stages, we act as an independent quality gate and trusted advisor for multiple teams at Allegro. In the simple terms, you can also think of our team as Allegro's AI kitchen. So we select and prepare the raw ingredients, human-created high-quality datasets, And we also test and tweak the recipes, LLM prompts, or shared language resources. And last but not least, we enforce one golden rule: human in a loop. Simply speaking, it means only human can taste a dish and say, yes, it's ready to be served to our precious customers. But as AI gets more advanced, quality verification gets harder, and I'm here to explain why. But before that, let's start from the foundations. What is an eval? So think of an eval as a test to see if your AI can do a specific job. You need 4 things to build one. First, a set of test questions. This is your test data set. Second, you need to define the task for the AI to perform. Third, you need to grade the AI's answers against the expectations defined in your dataset. And for this, you need to have an evaluator to produce a score. And fourth, you need a way to interpret the evaluation results. In other words, you need to check whether the score is good enough to pass the test. It sounds simple, but doing this well in practice is not easy. And the reason is, there are 2 major reasons. First, if your test questions are unrealistic, the test is not helpful, as it does not cover what actually matters. Second issue is where judge or quality criteria are too easy to pass. Then the test is misleading, giving a team a false sense of safety. Now, let's zoom out and realize that in reality, when we build an evaluation system, we have a whole menu to choose from. So let's imagine you want to assess the quality of the machine translation system. So first, we need to choose our test data set. Let's look at the left-hand side on the blue section. So we have first option, very obvious. We will just prepare the sentences and translate them by ourselves, by developers. This is, of course, slow and prone to bias. Therefore, the gold standard is examples from users. It's taking examples from users. Those examples may contain typos or peculiar syntax, but they are representative of how people actually use our system. And to have the ground truth for evaluation, we also need to manually translate and annotate those user examples. For example, mark specific samples as difficult or out of domain. But it may happen we don't have real data from users yet, so then we can use synthetic data. It's a fast and cheap method, but similarly to developer-created examples, it can be too clean and therefore unrealistic. Okay, so right now our data set is ready. Let's examine the task. So let's focus on the bottom part in red. The first question is, are we testing a simple MTE system or multi-step localization agent which uses external knowledge bases? It is very important to know because what works well for translation or simple LLM engine may not be optimal for testing other things. So, of course, for example, translation evaluators won't help us with chatbots, and they are also not very useful for evaluating image or code generation agent. So the bottom line is that we must always be aware of the proper evaluation method for specific target task. Okay, so now we need to decide on the evaluator. So let's focus on the top part in green. We have 3 main choices. First, humans. This method is highly accurate, but as we also know, slow and expensive to scale. Second option, simple automated rules and code. For example, spell checkers, regex, etc. Such heuristics can instantly detect typos or broken formatting, but those are completely blind to actual meaning. So the third option is to use LM as a judge adjusted to our quality criteria. It works well at scale, but we need to remember this method still needs human experts to verify the judgment of AI. And of course, we can combine multiple methods to have the best from all of the worlds. Now, knowing our task, feasible methods, and budgets, we must choose between comparing AI output against human ground truth or so-called referenceless methods, which analyze only AI outputs. And the last decision when designing evaluation pipeline, we need to decide whether we want to assess the AI system output or compare two outputs to find the better performing variant. So we have evaluators set. The last step, we need to apply them. So let's focus on the right-hand side in yellow. First, we can use unit testing for checking basic functions. For example, we can instantly verify that our translation system does not open broken HTML tags or corrupt our web layouts, as we see from the discussion in the last session. Second, we can run eval experiments during development to prove that our newly updated model or prompt is actually better. Third option, we can use comparative testing. For example, we run tests on a fixed data set to compare performance over time, or we are just making sure we don't make quality worse. And this can be done. This can be run automatically in so-called offline testing mode, but we can also run evaluation online to monitor quality in production and prove our sponsors that we are capturing the errors and we are meeting strict quality targets. So there are many options in this menu. And why do we need so many of them? Because agentic AI systems pose specific challenges. So right now, let's focus on them. On the left-hand side, you see traditional machine translation system or standard LLM. What's important, it is just a linear path. You give it an input, the model processes it, and outputs a result. The processing is done once. Now, let's look at the orange box on the right. This is our localization agent running a so-called goal-driven loop. So instead of a single step, it continuously iterates. It moves through thoughts, actions, and observations before outputting the final result. And this agentic behavior is incredibly useful, but it introduces the 5 major challenges I will explain in a second. So first one is what good means is very context specific. We know from translations very well that what works for marketing copy doesn't work for legal domain. We also know that the level of details, tone, and format is highly dependent on the application and user. Therefore, if you want to evaluate agents effectively, we need to be able to track and recreate the exact context the agent operated within. Second, there are many correct processing paths, so or the thinking paths of the agents. And 2 agents can take completely different routes and both produce the same good quality output. So then the question of which is better boils down to which was faster and cheaper. Third, for all the bad outputs, knowing the processing path is critical. Why? Because we need to be able to replicate all agent steps to identify at what stage it failed and why. For example, was it a reasoning error that caused the agent to choose the wrong glossary, or was the bad output caused by the wrong data in the correctly selected glossary? They can manifest the same, but have completely different root causes. And because those errors in agentic systems propagate silently, logging and analyzing the whole process is very important. We also call it AI tracing. And we all know that an obsolete style guide or glossary can produce thousands of poor quality translations before it's detected. So the same applies to agents. The solutions to those problems is online quality monitoring using automated AI judges, but how they also need constant calibration and clear ownership to be trusted, which is the 5th major challenge with agentic AI evals. Okay, so now we understand the challenges. It's time to share a good news. The people who can solve those challenges are in this room. Let me explain why. I think dealing with agentic AI quality is actually quite similar to managing human translation processes. It's all about guiding, reviewing, and calibrating a complex and subjective workflow. When engineers building AI agents worry that good is so hard to capture, is so context-specific, we as language experts can remain calm because we already know very well that localization is all about context. When engineers worry that there is no critical correct path, for you it might look very familiar because you know there is no single proper translation method and the choice depends on the content type, budget, timeline, etc. Third, when engineers realize a good final output can hide agentic process failures, you know, maybe even too well, that a beautiful copy often hides broken translation workflow. You also know how to troubleshoot it. So there should be no surprise with how agents are troubleshooted. Finally, when engineers, the fourth parallel is when engineers fear silent cascading errors, you can relate because you know what happens when a glossary error runs through the whole project and how hard it is to detect it and fix it. Finally, when engineers struggle to keep AI just consistent, you already know how to do calibration because you've done it with the unpredictable humans for years, and you can also do it for similarly unpredictable AI systems. So my point is that language experts don't need to reinvent themselves so much. They just need to adopt some new tools and strengthen their engineering mindset. And they simply need to manage their guides, glossary, and unique expertise in a more structured, scalable way. So simply speaking, localization experts are not behind this AI wave, they are ahead. And I know what you might be thinking. Okay, we have these transferable skills, but where should we actually start with this agentic evals thing? So let me show you. Let's look at this 5-stage evaluation lifecycle. Stage 1 is LMS as a judge. This means using a general AI model like Gemini to grade another AI model's output. It is super fast to set up, but it only gets you to about 70% accuracy. To make it safe for business, we must enter stage 2, expert refinement. This is where your unique domain expertise comes to play. You find the edge cases in user logs, build gold standards, and refine the rules. This improves judge accuracy from 70% up to 95%. And it's important that quality jump is driven by the human expert, not better, more expensive AI model. Once we have an AI judge we can trust, we unlocked stage 3, evals-driven development. Engineers can now use our AI judges as a compass to build twice as fast. They can run experiments, edit prompts, and instantly see if they made quality better or worse. And then comes stage 4, cost optimization. Running a general purpose AI engines like Gemini, OpenAI GPT, or Claude is very expensive. But once we define our exact quality criteria, we can use smaller, specialized models. Because they do just a single job, they can do evals as good as big models, but 10 times cheaper. And the final stage, E2E guardrails. E2E, of course, stands for end-to-end and means we evaluate the entire user journey and all AI systems components in real time. So think of guardrails as a safety nets on highway. They are those fast automated checks running on live traffic. If an agent makes a mistake, the guardrail instantly catches it and blocks it before even a user sees it. So now, as the owners of those evals, as language experts, you can move from quality checking to enabling strategic decisions. Let me show you 2 examples of agentic AI product trade-off. First, development phase. The goal is to balance quality versus cost. The sponsor asks, can we switch to a cheaper model? And expert brings the data showing that for cheaper model, quality drops from 92 to 87%. Then the product team can assess the decision to reduce the cost given the impact on the system performance and user experience. Second scenario is production monitoring. Here, the business might want to trade coverage for certainty. So imagine a scenario in which after growing number of incidents reported by users, a sponsor asks, can we improve the coverage of guardrails? But let's keep the budget fixed. So experts can show that cheaper model allows us to monitor 5 times larger traffic, but with greater risk of false alarms. And then the sponsor can make informed decision to increase the coverage at the cost of false alarms and not so precise evaluation scores. So the bottom line is engineers can calculate costs and latencies, but not quality. Only experts skilled in evaluation can put a number on what at stakes for our key stakeholders. And on the last slide, I showed you how evals give experts an opportunity to increase their impact. And this slide shows the progression. So it starts from step 1, curator. Here, you turn your daily QA reviews into structured data assets. These become companies' gold standards. Then you step up to become a builder. Here, you run evaluation experiments and design scalable AI judges. Your work as evals owner becomes critical intellectual property of the company. Finally, you reach the step 3, leader. This is where you partner with engineers and business leaders to adopt the best practices for evals across all AI products. And important, as an expert, you don't have to walk this entire staircase to add very huge value. Step 1 is much closer than it looks, and it has the largest return investment. And of course, the development of AI systems actually never ends. We prepare data, we test it, deploy it, find the gaps in production. Then every gap becomes a new training data and insights for the next cycle. And because language is alive, product requirements change, and models drift, this loop has no end. Therefore, the expertise is needed continuously. And this brings us to the last question: how to adopt and maintain evaluation at scale without hiring a massive team? So the common error is to think of evaluation as a temporary one-time project done just at the beginning. And some organizations try to either outsource everything or build it all internally. I think neither is good for the long-term maintenance. The solution I believe in is presented on the slide. So on the left, we have internal team, what's called the brain of the operation. This team decides what good means, owns the rubrics, and manages calibration. On the right-hand side, we have external partners, and they scale across languages, enables continuous operations, and catch all the internal team blind spots through independent validation. And this is the winning combination for building a permanent, highly efficient evaluation engine. So, to conclude, if you remember only one thing from this talk, let it be this: the more autonomous AI becomes, the more it needs people who define good. And your test data sets and rubrics are core intellectual property that enables governing AI systems at scale. But there is no AI magic, and we all know it. So those tools don't scale QA on their own. Skilled people do. So in our workshop in 15 minutes, together with Maria, Agata, Monica, and Jana, we will cover the essentials in 4 practical steps to get you started: ground truth annotations, experimenting with AI judges, baseline meta evaluation, and how to improve AI judge by adding domain expertise to the prompts. So